Okay, the Dr. Martín Hadad, he comes from Dendroclimatology Laboratory of Arizona Institute and Museum of Natural Science, National University of San Juan, Argentina. About his biography, the Dr. Martín Hadad is a biologist who earned his PhD at the University of Cordoba. His work focuses on tree and shrub species from Patagonia and the Central Andes to study the relationship between terrain and climate variables, as well as the effects of climate change on growth. He also investigated extreme climate events such as frost rains and interannual density fluctuations, along with biological phenomena like years of high seed production. The topic that he will speak in this Ecuadendro 2025 conference is about dendroclimatological and dendroecological studies from North Patagonia and Andes, Central Argentina. So you are welcome to these conferences. They are Dr. Martín Hadad.
Okay, thank you very much for the invitation to participate in this conference. I am very happy to share our study with the people from different parts of the world. So, well, I don't know how I can share my screen here.
Ya.
Ah.
En la parte de abajo, donde dice compartir. Sí, está habilitado.
Claro.
Sí.
Ok.
Está solicitando. Ok, ahora vamos a habilitar. Quizás allí. Okay. Inténtalo. Inténtalo otra vez.
Okay. Okay, I don't know what happened.
Yo lo tengo activado ahora. Lo tuve activado. Dice, varios participantes pueden compartir.
But I don't know, I pon compartir pantalla. Here, now. Okay, now. Yeah. You can see my screen.
Yes, it's possible to see you and hear you.
Okay, perfect. Okay, thank you very much for again for the invitation to participate in this conference. So, well, my name is Martín Hadad. I am working in the laboratory of the Dendroclimatological in Arizona in San Juan, in CONICET, and I will talk about our study, some result that we published in this during the 3 or 4 years, and another result that we are working yet. So, well. We know very well that global warming is influencing in the frequency and intensity of the extreme climate event, including the drought and event climate extreme. Also we know that the climate model project drought of a strong intensity and longer persistence in many arid and semi-arid regions such North Patagonia. So you can see here that like this picture, a little river now is dry, or many animals died, and like the similar another region during the last 40 or 50 years or more, the temperature are increased, yes, and the precipitation is decreased. So this condition is not very favorable to grow the different species of tree species or shrub species. So it's a complex land. So another thing that I want mention is about the climate of the South America in general, the climate of South America is influencing for two forcing climate, and this forcing climate come in from in the north of the South America. The winds that come to the Atlantic Ocean cross all the continent and go to the Pacific Ocean, and some part of this wind go to the south, and another part of the wind go to the north in the Ecuador meridional. And another important system is the middle lattice storm track in the south to the continent, and this storm track is influencing for the Pacific anticyclone. Yes, this anticyclone in the winter go to the north and produce that the precipitation that come in this with this wind produce more precipitation in, for example, in central of Chile. And in the summer, this anticyclone move to the south and produce more precipitation in South Patagonia and North Patagonia. Well, this two system is very well. Well, we know that the name is the El Niño Southern Oscillation that produce effect in all the continent, and another system is the Southern Annular Model. So these two large climate influence have a strong influence in the climate of the South America. And we can see here in this figure that Ricardo Villalba that they have a influence on the different species along the mountain Andes. So, well, another thing, another way is I will talk about the shrub. During the last maybe 10 or 20 years or more, many study show us the potential of the shrub in the dendrochronology. So we can start this kind of the form in area where we without a tree. So I think that it's very important extend the chronology with the shrub, because in many parts of the, for example, here in the mountain Andes, there are not tree. We can find only shrub. So it's the only way to study, for example, the ecology and study the paleoclimate history in the region. So I think that is very important for us start to study the shrub. Well, here we can see a paper from the Professor Lian that he showed the chronology around the world of the shrub. So we can see there are the little a few chronology. Maybe now there are more, but well, I think that we need to explore more species, shrub species. Another thing important is the Andes mountain is the most biodiversity region on the planet, and is the second highest mountain range after the Himalayan. So it's the environment, very important, and of course, this kind of the ecosystem experience extreme sensitive to climate warming. And we can see here that in the central Andes, in general, there are shrub species and little tree. Okay, and well, this figure is the paper from the Aguilera Betty that show us the chronology that there are in the International Tree Ring Bank, and we can see that the almost all the chronology are in the North Patagonia and South Patagonia, and specific in Tierra del Fuego. But there are important gap in the of record of the chronology in Central Andes. So I think that is well, it's good time to start to explore this region and see different potential species with for study dendrochronology. So, well, I show you in this presentation and in general study in North Patagonia and Central Andes, and specifically in North Patagonia, I will describe the spatial and temporal distribution of drought, frost rain, and intra-annual density fluctuation record in trees in the North Patagonia. And in Central Andes, we'll show the different or one species in special that we are using to see the relationship between climate and growth and try to understand the ecology of these species. Well, in special in Central Andes, we want to extend the network of the growth ring chronology to explore more with this kind of the species. Well, the first study that I want to show you is the reconstruction of the space. The space is the index draw, and I work with the Austrocedrus chilensis tree that this species grow in North Patagonia, in Chile, and Argentina, and it's very the ring of the Austrocedrus is very clear, and I used three sites, three forests for this study, and we took a living tree that we can see here in the picture, and they are good too to extend the chronology because the good of the Austrocedrus chilensis preserve very well after the die. So we can find good preservation, maybe that die 5 or 6 or more 100 years after that. So well, I compared with the space with the 1 month, and we can see here that is the good relationship with the November and December months of the space 1, the 3 sites. So after that, I make the reconstruction, and we can see here that the reconstruction is for the last almost 1,000 years. And we see here a different period with where the hydroclimatic condition was very well, and another no well, so more dry and more wet. Yes. And I compare with the reconstruction with the two forcing climate is SAM, and we can see here that there is a relationship, a significant relationship with SAM for the last 80 years. And another climate that uses the tripolar index that is similar to the variability is similar to ENSO, and well, is have a significant relationship with this forcing. So we can see that this two forcing climate affect the tree ring growth of the Astrocero chilensis in North Patagonia. And also, I compare the reconstruction of the space with another two reconstruction of the El Niño, 3.4 and SAM, the southern annular model, and we can see that in different periods there are some synchrony between the space reconstruction and these two forcing. So we can see here that maybe during the last 900 years, this forcing climate affect to the growth in North Patagonia. Well, another climate event extreme that we are working is frost rain. Frost rain is a special event that this event is take time in when it start the period of growth here in South America and the hemisphere, southern hemisphere start the growth in September, October, and maybe in September, October when we have some frost affect the growth. How we can see here in this picture, when the temperature is below to 0 or 5 Celsius degree, produce or kill all the cell and deform completely the cell. So we can find this kind of the form in the ring. Well, in this case, I work with the Araucaria araucana, that is another emblematic species in North Patagonia that grow also in Chile. And I study 6 sites to see the frost ring. We can see here the site, and for example, in the first 3 sites, there are a lot frost ring, and in the another site there are not so much frost ring. After that, I with a chronology, frost ring chronology, to compare with the climate and try to see what kind of event produce the frost ring. So when I compare with the sea surface temperature, I see that for the month that start to grow the ring in September, in October, November, and December, there are a relationship, negative relationship with the sea surface temperature, and this this kind of the relationship, we can see that that is the La Niña patterns. So in this when the La Niña years here in North Patagonia is more dry, and the condition to produce more frost rain could be more frequently. So well, with this happened with the frost rain in Araucarian. Another thing, or another climate event that we are working now is interannual density fluctuation. In this case, in Astroceros chilensis. We can see here in this two paper the interannual density fluctuation in different rain, different years. Well, we now we are working in the North Patagonia with Astroceros chilensis in 3 sites to see the distribution, spatial and temporal distribution of the interannual density fluctuation. And we can see here in the 3 sites that during the last also maybe 900 years we can find this kind of the event. And during the last 100 years, in the three sides, we can find that this kind of the ring, the interannual density fluctuation, there are more in special between the 14 and 17. It's very strange to this. We will try to know why this distribution. And if we compare the chronology, the interannual density fluctuation chronology with the temperature, in special November and December, we can find that this correlationship is positive. So if there are more temperature, there are more interannual density fluctuation rings. And then, after that, in December, when compared with precipitation, also is positive. So again, if there are more precipitation in January, there are more interannual density fluctuation. And if we took the meteorological data of the temperature and precipitation, we can see here that if we take only the year with interannual density fluctuation and without the year without interannual density fluctuation, we can see that it's a very small difference, but the years with the interannual density fluctuation is more high than the year without interannual density fluctuation. So the temperature is more high for this year during September, October, in November, and December too, in particular. And then if we compare the precipitation, the years with and without interannual density fluctuation, we can see here that in December and especially January, the years with the interannual density fluctuation years is more high. So we can see that this is that first, to form interannual density fluctuation ring, we need a high temperature during November and December, and then we need a precipitation to form, in this case, the late good, and then start again with the early good. So because the rain start in September, October, with early good, and maybe during November and December, and start to form the late good, and then after January, start again the early good, and in February or March, um, form the late good. So, well, this is the condition that we can see here that we need to form this kind of the rings. And another one topic that I want to share is the study that we are working in the institute and laboratory is the SRAP, and during the last 5 or 6 years, we are working with this species, Adesmia pinifolia, and we found that this species have a good potential to work with the dendrochronology, and this species grow up to the 3,000 meters. We can see here, this is the environment where grow the species. Also, we can find that good preservation, yes, to extend or score the chronology. Well, and in this paper, we show that the chronology is more or less of the 400 years, and have a good relationship with precipitation, especially with the September and December of the current growth period. With temperature, we don't find a good significant relationship, and we find a good relationship with the space with 12 months, almost all the months. So, well, but we compare this correlationship during the one period, so to see the stability, temporal stability of this relationship. We can see that in this case of precipitation is very stable, and temperature more or less, maybe in particular some months start to have a negative relationship for the last maybe 30 or 40 years, and with the space more stable. In this picture, to the right, we can see the spatial correlationship between chronology and space. So have a good relationship, spatial relationship, in particular to the north of Argentina. If we compare with the sea surface temperature, we can see that they have a good relationship with the temperatures of the Pacific Ocean, and this kind of the relationship is the La Niña condition. And again, I repeat, when the La Niña years is more dry in North Patagonia, in Central Andes too. And well, the next step that now we are working is about the relationship of this chronology, this species with the soil moisture, and we can see here that is a good spatial relationship, and it's possible maybe to do a reconstruction of the soil moisture for the last 400 years, and this is very important because in this part of the Central Andes there are not a paleoclimatical record. So well, we can try to to explore more with this topic. I think that this year or the next year, I hope. Another thing that we are working in this time is continue with the more sites in Central Andes, in San Juan, in Mendoza. In this case, one student, PhD student, Evangelina, She is working with the Adesmian and to analyze the pattern and drives of the Adesmia binifolia grown along latitudinal gradients in Central Andes, and try to see if there are some synchronies in this site or no, because this the distribution is maybe more than 500 kilometers. And another study that we are working now is well, in this case, Edgardo, that is a postdoctoral student, Edgardo Melian, and he is working to analyze the variability of the radial growth during the last 7 years in Adesma binifolia 2, and try to relate this climate functional trends. In this case, the leaf area, specific area, we can see here that he is collecting leaf to study this functional trend. He tried to relationship this functional trend with the chronology. And also, well, the last year we started this project with the college, with the Institute of Tibetan Plateau Research from China. And in this case, we will try to compare SRAP from Tibetan Plateau and Andes, Central Andes, and try to see what is the what pattern and see the extreme climate event that affect the growth, and try to reconstruct the decadal variation of the shrub recruitment, and try to identify the climate drivers that control shrub recruitment. So, well, this is for the future, but I hope that we can show you this result in another conference, maybe. So, well, to finish some conclusion, Astrocedrus chilensis, well, the spatial and temporal relationship associated with the solar and polar model of Pacific sea surface temperature variability indicate that the temporal variability observed in the space reconstruction is modulated by hemispheric scale atmospheric circulation dynamics. And in the case of the internal density fluctuation, we see that the dry to wet condition to form this kind of the ring, the density fluctuation. In the case of Araucaria, at the atmospheric scale, we found that the atmospheric circulation pattern related to La Niña years where it's associated with the regional frost ring record. And in Central Andes, we'll try to develop of a new network of chronology with the SRAP. Is possessed a challenge to understand the paleoclimate history and ecology of the Central Andes. So what is the next step that we will try to do? So I think that is all. Thank you very much for your attention. See, we are in time.
Thank you so much, Dr. Martin Hadad. Very interesting your presentation, and congratulations.
Thank you.
Okay, we have question here from the Dr. Mahmouda Islam. You're welcome, Doctor.
Thank you for this is a very nice presentation. I really like it, and especially for sharp chronology and interannual density fluctuation chronology. I'm really got a interest on that, and it's very interesting. All the studies are very interesting, and the presentation, the way of presentation is very nice. I have only some query, like I want to know, and I want to do some work with them, with you, and with the sharp chronology. How do you identify the sharp? Like, how do you identify sharp? This is my first questions. And second one, how do you get the annual soil moisture data? It's my query, not the like a, if you have some explanation, then can give, or some idea you can provide me. Thank you so much.
Mm. Uh, Sorry, the first question is shrub for
Yeah.
shrub.
Yeah, how do you identify sharp? Like, do you have any book or anything else that this sharp from the growth ring or not? How do you identify the sharp
The
species?
shrub,
Sharp species, yeah.
the shrub species. Well, we identify it because the we know that where this species grow
Yeah.
in the Andes mountain, and we'll try to visit this site. And well, sometimes it's very complicated to arrive to this place because, for example, in this picture you can see here that is the inside of the mountain, of the Andes mountain, and it's very complicated to arrive to this side and try to find the shrub species. But we know in some place where grow. So well, it's more or less it's easy, but sometimes no, it's easy. So what?
Yeah. Yeah.
And the
And
second, sorry?
yeah. And second one, how do you get the annual soil moisture data?
Yes,
You Yeah.
annual. No, we get for months data.
Month. Okay.
Yeah.
Then how do you get the soil moisture data, monthly soil moisture data, like a 400 years? You you
Yes.
mentioned, yeah, it is 400 years soil moisture data. How do you get the soil moisture data, 400 years annual or monthly data?
Months. Well, there are many, well, many no. There are some in the website, for example, in the climate, the site is a Climate Explorer site. Yes,
Okay.
you can find in this site
Okay.
the data, some more data. Also, you can find in this the website from NASA, but the name is Giovanni. Giovanni, that is in this site you can download data if you want. I maybe after I can send you the website to
Yeah.
download.
Yeah, it's nice. It's nice. Thank you so much. Yeah.
Mhm.
Thank
No,
you
thank
so
you.
much.
Thank you.
Thank you so much there, Dr. Mahmuda, for your question. We have more questions here from Daniela Robles after Tanvir. So you're welcome, Daniela.
Hi, thank you so much, Martin. I really enjoy your
Mm. Thank you.
presentation. I was just curious because you mentioned frost events and how they are recorded by Araucaria.
Yes, at a
And
very on.
I just wanted to know if that's the main disturbance, natural disturbance in these ecosystems, or if you can describe if there are other natural disturbances, maybe fire or.
No. In this case, is we know very well that this is frost. There are many studies that describe this kind of the form of the cell uh, after that produce the frost. Yes, so we know that this, for example, in the picture that I show you, is the frost ring, not another kind of the storm like a fire. Fire is sometimes different. Is in this case, we know that it's frost.
And one more thing, would the scar of the frost event be visible to the naked eye, or you always have to do a microscopy to see them?
No, you can see in the when the you see in the well, microscopy, but you no need a cut as an anatomical cut. When you see during the we do the cosecha or the yeah, you can see very well the frost ring.
Okay, because the picture you showed, it looked like it was from a microscope slide. It was just sanded, polished.
Yeah, well, in this case, just for showing this, well, in the paper, but no, you can see very well in when you put the sample and just sand the sample, you can see very well in the frost ring. No need
Wow.
do the anatomical cut, yeah? No.
Okay, thank you very much.
No, you're welcome. Thank you very much.
Thank you for your question there, Daniela. So we have more questions there, Dr. Martin.
Yes.
Tanvir, please, you are welcome. And after Marcelino, okay, you can start, Tanvir.
Okay, Kelly, thank you.
You're welcome.
Hello, Dr. Martin. Very informative presentation. I really enjoy it. I have
Thank
a
you.
very general question because I joined late. So I have very general question. Actually, I also want to study this El Nino as well as La Nino effect in Pakistan. So I want to know what is actually the threshold value of precipitation as well as temperature for this El Nino as well as La Nino phenomenon. I think I have given you my point of I want to know.
What happened with the La Niña years in Pakistan? And
Actually, doctor, I want to start research, especially reconstruction, and
yes,
we want to see what El Nino as well as La Nino events has been happened in our
yes.
area by using tree rings. So actually, I want to know what actually the threshold value of precipitation as well as temperature we generally consider to find out these events.
I think about I think that is similar because in Himalaya region is the opposite effect to South America. When, for example, here is El Niño event, there are more precipitation in Himalaya region. I think that is similar in Pakistan, maybe is decrease the precipitation and also the opposite La Niña here is more dry and Himalaya region is there are more precipitation, so I think that is the opposite when happen these years. So but you need to try to compare the different index because you know maybe the Niño 3.4 or 1.1 or maybe 4. I know because sometimes it's different how affect in different parts of the world. And there are there are some studies that relation the growth in China. But I know in China because I work with another college in China, so I am reading many papers for China. So I think that this is the relationship with the Niño and La Niña years. But yes, I have effect. I think that the Niño affect also Pakistan. I think that is possible.
I think I can add some points here. Kelly,
Sure, madam.
can I tell
Yes,
something? Yeah.
yes. Thank you.
El Nino and La Nino events, especially the sea events, and it doesn't have any threshold limit of precipitation and temperature. In one side, if there is a El Nino events, the precipitation increase, and if another side opposite side La Nina happen,
Yes.
then precipitation decrease. There is no threshold limit. It depends on the site to site and special
Yes.
events of, yeah.
Yes.
Thank you so much for this
Yes.
interesting
Thank you.
Okay, sir.
issue.
Sir, thank you so much. And I also want to know what is the, you can say, trustful source to study this El Nino as well as La Nina, you can say, phenomena. Actually, I want to know what the source I have to use for temperature as well as precipitation for Pakistan.
Okay. I don't know, is the question or no?
Yes. I meaning to say, should I have to use CRU data or some other sources for temperature and precipitation?
The data, precipitation, and temperature.
Temperature.
Sorry,
Source of data.
So?
Is it Climate Explorer or any other source?
The
Okay.
data. Okay, yeah, sometimes the climate explorer too, and sometimes meteorological data. But in this case of the paper that I showed is the frost ring is the climate explorer, but when make the reconstruction of the space reconstruction to compare the SAM and ENSO. We use for data for ERA 5. That is another kind of the data, satellite data, and well, it's different.
Thank you so much, Doctor.
No, thank you. You're welcome.
Okay, we have another question here, and while there, Dr. Dave, I know that you will start now, but with my presentation from Kelly Peña is a little short, so we have a little more time for your presentation if there are no problem. So this is the Marcelino have another question. Marcelino,
Okay.
you are welcome.
Hi, good day to everyone. I am from Philippines. I am a forester here in the Philippines. So my question is, what are the methods to assessing dendroecological to reconstruct defoliator outbreaks in northwestern Patagonia, like in your place, Mr. Martin?
But I know use I know use the foliar outbreak to do reconstruction. I know that there are some paper in North Patagonia that try to reconstruct the foliar outbreak, but I never work with this kind of the ecological event. I don't know. Sorry.
Okay. Thank you so much, there, Dr. Martin
Okay,
Hadad,
thank you, Mr. Martin, for that.
for your
At least
question. And we will make the